All right, today we're going to be writing linear functions in point-slope form. As you'll see, it's pretty useful for us when we are writing functions in any form really, but we don't have our y-intercept. 95% of the time with linear functions, you're just going to write them in slope-intercept form like we did in section 1. But as you'll recall in section 1, we were given our y-intercept with almost every problem, so we didn't have to do any work to find it. Point slope form helps get us there without having to do different little steps. There's always multiple ways to do something. Point slope form is still somewhat useful to us, but again, mostly it's for when we don't have the y-intercept in slope-intercept form. So goals that we'll be able to write in a line, given a slope and the point on the line. Again, it can be any point. Write an equation of 2 points, given 2 points, and then use linear equations to solve real-life problems. So first of all, you'll see here, I wrote out the slope formula down here at the bottom in blue, and you'll see that the point slope form really just kind of comes from the slope formula, but we multiply this x2 minus x1 off the bottom and put it with our value m. So again, take some time to write this down, understand y is always going to be there. It's our our output variable. X is still our input variable. So just like in y equals mx plus b, slope-intercept equations, it's going to be there for us. The other thing to draw some attention to in this is that there's negative signs here. So that means when I plug in a value here, this negative that's already there is going to have some effect on what the value is or what it looks like. So you'll see in the first example what that kind of looks like. So in this one, we have an equation, or excuse me, we have a slope given, and we have a point given. And you'll notice that it's not the y-intercept. So this is going to be kind of a scenario like we see later on down the road, except for it wants us to leave it in point slope form. So point slope form is y minus y1 equals m times a quantity x minus x1. The subscripts get the values plugged in. So our y value is 3. We're going to plug in, not equals, we're going to plug in 3. Our slope is 1/4. We're going to go ahead and plug that in. And then our x value is -8. But as you'll notice, when I plug that -8 in, it kind of looks funny. So we want to clean that up. So we leave y minus 3 alone. And then we have 1/4. And then times the quantity x plus 8. So basically the things that you see in point slope form are the opposite of the coordinate point that we're actually getting from it. But this right here is your answer if you're being told to leave it in point slope. Okay, so we have some examples here worked out. Again, you have blank notes in Canvas if you'll go to those and open those up and try and work those out and make sure that you can get these answers. There's another set of examples past this as well, but make sure that you can take those values and plug them in and then get your results here. So here's what we get for the first 2 answers. Now, as I go through the video, you'll see in the notes that there's another set of monitoring progress. Make sure that you can do those after the next couple examples that we do. So now, again, like I said, typically point slope is really only useful to us to write slope-intercept equations when we don't have the intercept given. So in this first example here, you can see our intercept isn't even on the page. We don't know how to find it. And what I'll do for this one only is I'll show you the work. Regardless of what point we use, we should get the same answer in slope-intercept form. So first thing we need to identify is our slope. So if we count, our rise from 2 to -2 is -4. Our run from 1 to 3 is 2. So we have a slope of -2. Now from here, I'm going to use this point first and plug it into point slope. So we have y minus 2 equals -2 times the quantity x minus 1. Now it wants the equation in slope-intercept. So I'm going to distribute my -2 on the right. And I get y minus 2 equals -2x plus 2. And then I'm going to add this 2 to the other side. So I get y minus 2 equals -2x plus 4. Now, just to show you, it doesn't matter what point we use. As long as we do our math right and plug it in right, we should be okay. I'm going to plug in the other point. So for this one, it would be y plus 2 equals negative 2 times a quantity x minus 3. When I distribute the negative 2, I get y plus 2 equals negative 2x plus 6. And then I subtract the 2 over. So y equals negative 2x plus 4. So we do get the same answer. It doesn't really matter what we have. I forgot to cross that 2 out on the other side. So there is our answer on this one and this one. Sorry about that. I didn't get that 2 crossed out right there, and that wasn't supposed to be there after I added it to the other side. But we have it correct. Okay, so again, we have another example here. This is kind of similar to what we saw before. We have a function notation. So in other words, instead of y equals mx plus b, we're going to have f of x equals mx plus b for our answer. We still want to utilize these as coordinate points. We still need to find our slope, so I'm just going to do 4 minus negative 2 over 8 minus 4, and I get 6 over 4, which reduces to 3 over 2. Now I'm going to just pick a point. I'm just going to go ahead and pick this one. So I have y plus 2 equals 3 over 2, x minus 4. I distribute my 3 halves, so y plus 2 equals 3 over 2 x, and then if I take 3 over 2 times 4 over 1, those cancel, and I get minus 6. And then I subtract that 2 over, and I get y equals 3 over 2 x minus 8. And so there's my answer in function notation. Okay, so again, process is no different. We're just using point slope, converting it to slope intercept. Okay, so if you need to pause, back up, and re-watch any of that or rehear any of that, make sure you do that. Again, in Canvas, there's the whole chapter of blank notes. You can open up and go to the second section. You can scroll through it and work these out. I have the solutions here. That way you can see what they look like worked out. Okay, so again, right there, there's those. If you want to pause the video right here and just work them out, then that's fine. But here's your solutions. So in the first one, you can see I found the slope of 3, and then I plugged in the first point, and I got y equals 3x plus 1. Number 4, again, we found our slope was negative 1/4 by using the slope formula. I just plugged in the first point, negative 4, negative 1, and then I converted it to slope-intercept by isolating the y. And then the last one, again, we have the coordinate point 2, 3, and 6, 5. We do our slope formula, we get 1/2. I just plugged in my first point, and I got y equals 1/2 x plus 2. And again, a better answer there, and I kind of dropped the ball, a better answer there would be g of x equals 1/2 x plus 2. Okay, the last one here, again, you guys, you'll see these from time to time where they give you a table of values. I need 2 points. I want to write an equation of a line. So it says write a linear model. That's slope-intercept. That's what we need to do. So I'm going to do 46 minus 34 over 6 minus 4, and I get 12 over 2, which is 6. That's my slope. Now I'm just going to pick the first point, and I'm going to do y minus 34 equals 6 times the quantity x minus 4. So I have y minus 34 equals 6x minus 24, and then I add the 34 over, so I get y equals 6x plus 10. And there's my linear model for that situation. Okay, so again, the learning goals was to be able to write an equation in point slope, but really understand the bigger objective is that we need to be able to get that to slope intercept, and it's useful to us because we don't need to know our y-intercept to get it there. Make sure you guys ask any questions if you have them. Otherwise, good luck on your homework. Have a great day.